In this lesson, we will discuss methods to integrate trigonometric functions. Now, from the expertise you have so far, you know how to integrate, say, sine to the power of 7x cos x dx. Now, this is simple because we can make a substitution, sine x equal to u. Then cos x dx will be equal to du, and this integral will become u to the power of 7 du, and that can be integrated. Now that means in order to integrate a higher power of a sine function, you need a cosine along with it. In the same way, if I want to integrate a higher power of cosine, let's write down one such function. Integral of cos cube x sine x dx can be integrated by making a substitution, cos x equal to u. Now, how would you do one like this? If I have say cos squared x sine cube x dx. What will be the method in here? Well, since the power of sine is an r power, we will write it like this. It will be cos squared x times sine squared x times sine x dx. And then we will write this sine squared x in terms of cos squared x. Remember this identity? Sine squared x plus cos squared x equal to 1. That means sine squared x is 1 minus cos squared x. You can bring it over here and simplify. You can do a simple substitution. Well, we will develop methods like this in today's class. But in order to do that, you must know all the basic integration rules using trigonometry that we reviewed in our 2.1, lesson 2.1. And also, you must know all the trigonometric identities. Well, let's start by reviewing those one more time. Well, we will quickly review some of these trigonometric formulae that we already know. Integral sine u du is negative cos u plus c. Integral cos u du is sine u plus c. Integral tan u is negative ln cos u plus c. Integral cot u du is ln sine u plus c. Integral secant u is ln secant u plus tan u plus c. Integral cosecant u is negative ln cosecant u plus cot u plus c. Integral secant squared u du is tan u plus c. Integral secant u tan u du is secant u plus c. Integral cot u cosecant u du is negative cosecant u plus c. Integral cosecant squared u du is negative cot u plus c. You got to write them down and learn this. It's very important to know them. And integral sine au du is negative cos au divided by a. We've done that before. Integral cos au du is sine au over a. Very important results. And the trigonometric identities, one more time we will go through them. Sine squared x plus cos squared x is 1, which means sine squared x equal to 1 minus cos squared x, or cos squared x equal to 1 minus sine squared x. 1 plus tan squared x is secant squared x. That means tan squared x equal to secant squared x minus 1, or secant squared x minus tan squared x equal to 1. Similarly, 1 plus cot squared x equal to cosecant squared x, which gives you cot squared x equal to cosecant squared x minus 1, or cosecant squared x minus cot squared x equal to 1. The double angle identities, we will use them profusely in this lesson. Sine of 2x is 2 sine x cos x. Cos of 2x is cos squared x minus sine squared x, which is the same as 2 cos squared x minus 1. That means if you have cos squared x, you can represent that in terms of cos of 2x. Can you write cos squared x in terms of cos of 2x? It will be cos of 2x plus 1 all over 2. Similarly, you can represent sine squared x in terms of cos 2x, and we will need to do that in this lesson. Alright, in order to integrate a higher power of cos x, there must be a sine x present in the interval. I just showed it to you in the beginning here. Now, this is because when cos of x is substituted as u, sine x will then serve as the du. It's very important to take care of that. Similarly, to integrate a higher power of sine x, there must be a cos x present in the integral. In order to integrate a higher power of tan x, what must be there? There must be what additional part must be present in the integral? Well, if you look here, in order to integrate a higher power of sine x, there must be a cos x present. Why? The derivative of sine x is cos x. Similarly, in order to integrate a higher power of tan x, what additional term needs to be present there? It must be secant squared x. You see, an integral like integral tan to the power of 7x secant squared x dx can be easily integrated. In order to integrate a higher power of cot x, what additional term must be present in the integral? The derivative of cot x is negative cosecant squared x. So there must be a cosecant squared x present in order to integrate a higher power of cot x. Alright, all these are very important concepts. So, integral sine to the power of 5x cos x dx can be easily integrated. Why? You can make a substitution sine x equal to u, then cos x dx will become your du. You can easily integrate it. Similarly, integral cos to the power of 5x sine x can be integrated. You can make a substitution cos x equal to u, then negative sine x dx will be equal to du. In the same way, integral tan to the power of 7x secant squared x dx can be easily integrated. Why? Because you make a substitution tan x equal to u, secant squared x dx becomes du. Alright, let's do a simple integration. Integrate sine cube x cos to the power of 4x dx. You notice here that the power of sine is odd and the power of cosine is even. Now, why are they significant? Because the power of cosine is even, we can represent this in terms of sine. You can change this into a sine function. How? Because cos squared x is 1 minus sine squared x. If cos squared x is 1 minus sine squared x, what is cos to the power of 4x in terms of sine squared x? We will do that over here. That means this sine cube x can be written as sine squared x times sine x. So when cos to the power of 4x is written using sin x, we will have all these in terms of sin x, and then you need a cos x to integrate that. Or, in this case, we will represent all these functions in terms of cos x. You see, sin cube x will be written as sin squared x times sin x. And sin squared x can be written in terms of cos squared x. How? Sin squared x is 1 minus cos squared x. And then there will be a sin x left over to take care of our du. Well, I talked too much about this. Let's do that. Now here the power of sine is odd and the power of cosine is even. An even power of sine can be converted to cosine using the identity. What identity is that? Sin squared x equal to 1 minus cos squared x. So what we will do is we will write this sin cube x as sin squared x times sin x. We will write the sin x dx at the end. So this will be sin squared x times cos to the power of 4x times sin x dx. That's right. So let's write that. Integral sin cube x cos to the power of 4x dx is integral sin squared x cos to the power of 4x times sin x dx. You understand the rationale before writing this? Yes, because this sin squared x can now be changed to cos squared x using this identity. And we can then make a substitution, cos x equal to u, then this sin x dx will become du. That's the rationale. So we convert now sin squared x to cos squared x. Convert this sin squared x to cos squared x like this. So you have, that will be equal to, in integral, sin squared x become 1 minus cos squared x times cos to the power of 4x sin x dx. If you now distribute this cos to the power of 4x, what will that become? Well, before distributing that, let's do a substitution. Substitute cos x equal to u. If you substitute cos x equal to u, take the differential of both sides, we get negative sin x dx equal to du, and therefore what is sin x dx equal to? Sin x dx equal to negative du. So when these cos x becomes u, sin x dx becomes negative du. So look at the way this integral is transformed. It's equal to 1 minus u squared, cos x equal to u, times u to the power of 4 times negative du. And this negative, we can take it out and distribute this u to the power of 4. It will be u to the power of 4 minus u to the power of 6. So negative integral u to the power of 4 minus u to the power of 6 du, and that is something that can be integrated very easily. What is that now? Integral u to the power of 4 du is u to the power of 5 over 5, so that would be negative. U to the power of 5 over 5 is integrating u to the power of 4 du, minus integral u to the power of 6 du is u to the power of 7 over 7 plus c. What all we now need to do is, well, we distribute that negative. That gives us negative, negative become positive. So I'm going to write this first. U to the power of 7 over 7 minus u to the power of 5 over 5. And replace your u by cos x. That will be cos to the power of 7x over 7 minus cos to the power of 5x over 5 plus c is that integral. So look at the details of what we did in here so that you can actually use it in later integrals. Another one. Evaluate the integral